So today we continue with velocity, acceleration, and displacement, which we're doing yesterday. We stopped with circular motion, and we said that motion in a circle is dealt with pretty much the same way that we do with motion in a straight line, except here our displacement is an angle instead of a length. Okay, so let's now look at some of the questions in the exercise. So I see we're making quite good time. We're supposed to take 4 weeks on this and the next section, but I think by the end of this week we will be done. So that's good. So you'll have enough time to prepare for the test. Okay, so the next exercise is exercise 1.7.1. But before that, let's look at the example that is given there. Okay, in the example that we are given, we are told that a particle moves along the arc of a circle according to the equation theta is equal to t cubed over 5 minus t, and then we are asked to find the angular displacement, angular velocity, and the acceleration after 5 seconds of movement. Okay, so that's not too difficult to do. So firstly, we want to work out the displacement after 5 seconds. So that's just a matter of substituting 5 into the equation for the displacement. So this is 5 to the power of 3 divided by 5 minus 5. That this gives us 20. Okay, and because this is an angle, remember we measure our angle in radians. So always include the units at the end. Then we want the angular velocity after 5 seconds, so we need to work out the equation for the velocity. So the velocity we said is d theta dt. So just differentiate this one, which is a very basic polynomial that you can differentiate. This is 3t squared over 5 minus 1. And then we want the velocity after 5 seconds. So we have 3 times 5 squared over 5 minus 1. Here get 14. And this is in radians per second. And then the last one is the displacement. So we want, not the displacement, sorry, the acceleration after 5 seconds. So we know that acceleration is the derivative of the velocity with respect to time. So this equation over here for velocity, we differentiate it. What do we get? This is 6t over 5. And then the acceleration after 5 seconds is simply 6 times 5 over 5, which is equal to 6 radians per second squared. So keep in mind that you should include the units and make sure you include the correct units. Now let's look at the exercise 1.7.1. First question, we are told that a particle moves according to this equation, e to the power of t sine t, and here our units are in meters. Now we have to determine the velocity and the acceleration after pi over 4 seconds, and our answer must be to two significant figures. Okay, so if we have the formula for the displacement, the velocity is just the derivative of the displacement. So v is equal to ds dt. So we differentiate this. So all the techniques we learned about in differentiation, we have to apply them here. So again, very basic, use the product rule. E to the power of t, as it is, the derivative of sine is cos, and then the derivative of e to the power of t is e to the power of t, and then sine t as it is. Okay, then we were also asked to work out the acceleration, so I can do all the differentiation at once and then substitute, or get this derivative and substitute and then do the other one. You can work it out in either way, that's fine. So our acceleration, this is dv dt. So we differentiate this with respect to t. So we start with this one, e to the power of t cos t. We have to use the product rule. This is e to the power of t cos t minus e to the power of t sine t. And then the derivative of this is this whole thing over here, because you see this part here, s, and this, when I got this by differentiating that. So to get the derivative of this one, I just write the whole thing as it is. So this is plus e to the power of t cos t plus e to the power of t sine t, and this is 2 e to the power of t cos t. So now I have my formulas for velocity and acceleration. I can substitute t equal to pi over 4. We say that when t is equal to pi over 4, the velocity, pi over 4, this, just substitute e to the power of pi over 4 cos pi over 4 e to the power of pi over 4 cos pi over 4. And we know that sine and cos of pi over 4 is square root of 2 over 2, or 1 over square root of 2. So we have e to the power of pi over 4 multiplied by cos of pi over 4 plus e to the power of pi over 4 multiplied by sine of pi over 4. So this is e to the power of pi over 4 over the square root of 2 plus e to the power of pi over 4 is the square root of 2, and this is 2 e to the power of pi over 4 over the square root of 2, which is just square root of 2 e to the power of pi over 4. So we want this answer to two significant figures. So what does the question say? It says two significant figures. So this is 3.1 radians per second. That's in 2. And then the same thing for the acceleration when t is equal to pi over 4. This is equal to 2 times e to the power of pi over 4 multiplied by cos of pi over 4, This is 2e pi over 4 divided by the square root of 2, which is also square root of 2e to the power of pi over 4. And this also gives us 3.1 radians per second squared. So to two significant figures, as the question asks us to do. Okay, let's look at number 2. Number 2, we are told that a car moves from rest in a straight line according to the equation S is equal to 100 t squared minus 2t to the power of 4. And t is in minutes and s is in meters. So take note of the units there. And the first question there says, how far has the car moved when it comes to rest for the first time? So you need to remember, what does it mean for the car to come to rest? When the car comes to rest, the velocity is equal to 0. So take note that at rest, the velocity is equal to 0. So we need to work out what is the equation for the velocity, equate that to 0, and then solve for t. So our velocity, this is ds dt. Differentiate the displacement with respect to time. This is 200t minus 8t to the power of 3. Okay, then we say the velocity is 0, so we say 200t minus 8t to the power of 3 is equal to 0, and now we want to solve for t. So we factor out t. We can factor out 8, I believe. Yeah, 8t. So 8t, get 25 minus t squared. This is equal to 0. So this tells us that 8t is equal to 0, or 25 minus t squared is equal to 0. So here for the first one, t is 0. For the second one, t is plus or minus 5. Now again, we're talking about time here, and time must be positive. So we take t to be equal to 5, and our unit of time is minutes, so t is equal to 5 minutes. So we know that it stops for the first time after 5 minutes, and what we wanted to do, what we wanted to work out was how far has it moved, or what is its displacement after it stops. So just substituting the t into the formula for the displacement. So s when t is 5, this is 100 times 5 squared minus 2 times 5 to the power of 4. So that you can do in your calculator. 100 times 5 squared, 2 times 5 to the power of 4. 1,250. 1,250, and our units are meters. So you can also include sentences to answer the questions, since these are word problems. That's also good. The car travels 1 to 50 meters when it comes to rest for the first time. Okay, so that is that one. That is number 2, part 1. Then part 2, what is the maximum speed? So for the maximum speed, you need to remember we get the maximum of something by differentiating, equating to 0, and then going back and solving to get the maximum. So what we need is the derivative of velocity with respect to time, which is also the acceleration. So dv dt, where is our v? V is here, so we differentiate this, we get 200 minus 24t squared. Okay, and then say that at the maximum, we know that v prime is equal to 0. So this means that 200 minus 24t squared is equal to 0. And then we can solve. So this means that t squared is equal to 25 over 3. And t is equal to 5 over the square root of 3 minutes. So again, we only, let me just show that. Say t is plus or minus the square root of 25 over 3, and then we conclude that the t that we are taking is the positive one because our time is positive. You cannot go back in the past where time is negative. Okay, so this is our t, and now we want the maximum velocity. So we should always check that this is in fact the maximum. So checking that it is the maximum means we have to work out the second derivative and then substituting in there and seeing that our answer is negative. So checking that it is a maximum, we work out the second derivative of v, which is negative 48t. Okay, and then we substitute 5 over the square root of 3. This is negative 48, 5 over the square root of 3. So clearly this is negative, and therefore it is in fact a maximum. Okay, then we carry on with what we were doing to actually work out the maximum velocity. So we say that our velocity or our maximum velocity, this is v of 5 over square root of 3, which is equal to 200 times 5 over the square root of 3 minus 8 times 5 over the square root of 3 cubed. Okay, so this is 694.444, and sorry, I'm writing the wrong answer. This is 384.900, and this is meters per minute. Okay, so the question doesn't tell us how many decimal places to leave it in or anything of that sort. So we follow what is usually on the question paper, which is to leave your answer to 3 decimal places. Then the third one says, where's the third one? How far did the car move before it reached its maximum speed? So that is talking about displacement. So we know that it reached its maximum speed after 5 over the square root of 3 minutes. So now we just need to work out what is the displacement when t is equal to this. So we already have the formula for the displacement. There it is, 100t squared minus 2t to the power of 4. We just substitute 5 over the square root of 3 there. And number 3. So 5 over the square root of 3. This is 100. And 5 over the square root of 3 squared minus 2, 5 over square root of 3 to the power of 4. So that, just type in on your calculator. What did I get? 694.444. And then this is meters. Leave our answer to 3 decimal places. Okay, now let's look at number 4. Number 4 says a body moves according to the equation S is equal to 2t minus t times ln of t, and this is measured in meters. Then we have to determine its displacement when its velocity is 0. So pretty simple question. We just need to work out the velocity. So we know that the velocity is s prime. So this is 2 minus. To differentiate this, we use the product rule. So first one, t as it is, then we multiply by the derivative of ln of t, which is 1 over t. And then here minus, because this minus or that minus will multiply by the plus over there. Derivative of t is 1 multiplied by ln of t as it is. Okay, so simplify over here. You can see that the t's will cancel. So I have 2 minus 1 minus ln of t, which is just 1 minus ln of t. And we're told that the velocity is 0. So this means that 1 minus ln of t is equal to 0. This means that ln of t is 1. And this means that t is e, or e to the power of 1, which is just equal to e. Now we are looking for the displacement. So now that we know what t is, we just substitute it into that equation. So the velocity when t is e, this is 2e minus e times ln of e. We know that ln of e is 1, so this is 2e minus e, which is just e. And our units are meters. Okay, then we go to number 8. We are given the formula for the displacement. S is equal to Q plus BT cubed over T. And we have to show that the acceleration is 2s over t squared. So again here, not difficult, very simple, because we know what our answer should be. So we're looking for the acceleration given the displacement. That just means we need to differentiate twice. So we start with the velocity v. This is s prime, and this here you can use the quotient rule if you like, or you can break this up as q over t plus bt squared. So this one here, you can rewrite it as q over t plus b t squared, which might be easier to differentiate than using the quotient rule. So if we differentiate this, we get minus q over t squared plus 2b times t. That is our first derivative. And then we get our second derivative, the acceleration. This is the second derivative of s with respect to t, or just v prime. So this one here, we differentiate this. When we do that, we get negative 2. So it becomes positive now. 2q over t to the power of 3 plus 2b. Now you have to keep in mind what we wanted to show. So we wanted to show that a is equal to 2s over t. This is what we wanted to show. So we need to rewrite this so that it's 2 times s, and this is s over here, and that has to be divided by t. So doing that, we play around with this a little bit. So you can see I have a fraction plus a number. You can rewrite this as a fraction. Use an alarm ring. Okay, it's fine now. So a is 2q plus 2bt to the power of 3 over t to the power of 3. So if I combine those as one fraction, and from here I write this as 2 over t times q plus 2bt to the power of 3 over t squared. Yeah, somebody's speaking, but you're very soft. Let's see.
Q and B like constants in the space?
Yes, they are. T. Let me just see here. Did I do this correctly? Okay, I see. So the squared here. Look here, I said it must be 2s over t squared. That's what I need to show. Okay, so we take out t squared like that. Then what we see is this is that, and that is S. So this is just 2 times S over T squared, which is exactly what we wanted to show. So there's a bit of differentiation, pretty simple. And then after that is just some algebra to make sure that it looks the way you were asked to make it look. Otherwise, nothing too complicated there. Then yeah.
Ma'am, but
Yeah.
you have t to the power of 3 in the denominator.
Which one are you talking about?
A equals to, there is,
Here.
yeah, why is it
Then the
to the
next
power of
step,
3?
I have 2 over T squared.
Let me first ask, did you factorize out 2 over t?
Yes, so there should not be a 2 there. So I did factor out 2 over T squared. And then what I'm left with over here is S. So it's 2 times S divided by T squared, which is what I was asked to show. Okay, then number 9. Let me see, what does number 9 say? Number 9 says the displacement of a body moving with a simple harmonic motion is given by S is equal to 2 sine pi t plus 3. Okay, and then this is in millimeters. Determine its velocity and acceleration when the time is 1 over pi. Okay, so we have the displacement. To get the velocity and acceleration, all we need to do is differentiate. So here, our formulas for the displacement are not too difficult. So differentiating is pretty easy. So V we know is S prime. So this is 2. The derivative of sine is cos plus 3. And then we multiply by the derivative of the inside, which is pi. So our derivative is 2 pi cos of pi t plus 3. Okay, and we can also work out the acceleration. This is S double prime or just V prime. So we differentiate this formula. So this is negative 2 pi because the derivative of course is minus sine pi t plus 3, and then we multiply by the derivative of the inside, which is pi. So this is negative 2 pi squared sine pi t plus 3. Okay, so now we have our velocity and acceleration formulas. Now we need to work out what is the actual velocity and acceleration when t is equal to 1 over pi. Okay, so we start with the velocity at 1 over pi. Substituted there. This is 2 pi times cos of pi times 1 over pi plus 3. Okay, so this is 2 pi cos of 4. So here your calculator should be in radians. Okay, so this is negative 4.107 to 3 decimal places, and our units, this is millimeters per second. Then acceleration when t is 1 over pi, this is minus 2 pi squared sine of pi times 1 over pi plus 3. This is minus 2 pi squared sine of 4. So again, here your calculator must be in radians. Okay, so I have 14.939. And then the units are millimeters per second squared. Always include your units. Okay, then number 10. We're told that a disk rotates through theta radians during t seconds according to the equation. Theta is equal to 10 minus 2t plus t to the power of 3. Then we want to find the angular velocity and angular acceleration after 2 seconds. So we have the displacement. We need the formulas for the displacement and acceleration. So we say that omega is equal to theta prime. So just differentiate this with respect to t. You get minus 2 plus 3 t squared. Okay, and then our acceleration, this is theta double prime or omega prime. So we differentiate this with respect to t, we get 6t. Then working out the velocity and acceleration at the time we are given, 2 seconds. So omega 2 minus 2, 3 times 2 squared. So just do that on your calculator. This is 10. And the units, this is radians per second. Then our acceleration after 2 seconds, this is 6 times 2, which is 12 radians per second squared. So all other questions involving acceleration, velocity, and displacement, you would do them in the same way. They are, of course, keywords that we expect you to know. Things like initial velocity, you should know that means time is 0. At rest, velocity is 0. When we say constant speed, that means it's not accelerating. So all those terms that I think as engineers, especially mechanical engineers, you guys will be quite familiar with. Then the last section of this chapter 1 on differentiation is maxima and minima. I have maxima and minima, which is also an application of differentiation. So we start with an example. We're told that an open cylindrical can has to be made out of metal sheet So words like open, that should tell you that it doesn't have a top, so it has a circle at, it is open on both ends, I suppose. Okay, has to be made out of metal sheet. So it's closed at the bottom because it's a can. Okay, it has to be made out of metal sheet with a predetermined volume of 2 liters. If the radius is r centimeters, determine the area of metal required in terms of r, then determine the value of r for a minimum area and find this minimum area. With these questions, whenever possible, draw a sketch to see what it is you're working with. So you have a cylinder like this. This is the radius. And then this is the height. Those are the dimensions that we give of the cylinder. Okay, so we know that it's open at the top, so we need to make the body and the bottom of this cylinder. So the area that we will be working with is the area of the circle at the bottom. So you can see there's that circle there at the bottom, this area here, and its area is given by pi r squared. And then we have the area of the body, or what we call the lateral area, and the formula for that is 2 pi r times h. Okay, now what else are we told about this? We are told that its volume must be equal to 2 liters. And here, because we're talking about radius and lengths, these are measured in centimeters according to the question. So we need to convert this liters to centimeters squared. So we know that 1 centimeter cubed is equal to 1 milliliter. So 2000 milliliters is 2000 centimeters cubed, because 2000 milliliters is 2 liters. So we know that our volume will now have to be 2000, and this is in centimeters cubed. Now the volume of a cylinder is given by pi r squared times the height. So we actually have the equation pi r squared times height equals to 2000. So this is an equation that we have. So with questions like this, you will have two you have an area and then you have a volume. And then usually what you can see that my area is in terms of two variables, there's r and there's h. And then with the other equation, what you have is a way to, it also is in terms of the two variables. So you can see this is also in terms of r and h. Now with the second equation, you have a number this side, so you can make one of the variables the subject of the formula and then substitute it in there. Okay, so you always want to pick the variable that will make your substitution easier. So here, making h the subject of the formula will be easier to work with when I substitute it in there, unlike making r the subject of the formula. Then I end up with square roots there and it's more complicated, and you always want your life to be as easy as possible. So from here, we can see that h is equal to 2000 over pi r squared. Then what we do with this h is we will substitute it into the formula for a. Then our formula for a will be in terms of only one variable. And when it's in terms of only one variable, we know how to work out the maximum or the minimum. You differentiate, equate to 0, and then you use the second derivative to test that it is in fact the minimum. So doing that, the substitution, we have the a is equal to pi r squared plus 2 pi r. Then instead of h, I put 2000 over pi r squared. Okay, simplifying, this is pi r squared plus, you can see the pi's will cancel, r's cancel, you're left with 1r, and you have 2000 times 2, which is 4000 over r. Okay, so now we can differentiate because this is only in terms of one variable. So differentiating, this is 2 pi r and then minus 4000 over r squared. Okay, so we want the minimum area, so we need to equate our derivative to 0. So we say that at the minimum area, a prime is equal to 0. So we have 2 pi r minus 4000 over r squared is equal to 0. And then we just solve for r. This means that 2 pi r to the power of 3 minus 4000 is equal to 0. This means that r is equal to the cube root of 4000 over 2 pi, or 2000 over pi. This is the cube root of 2000 over pi. Okay, so we want to test, will this in fact give us the minimum? And to test that, to test whether or not this gives us the minimum, we need the second derivative. So to test whether it is minimum, we use the second derivative test. Okay, so we need the second derivative. This was our first derivative, so we differentiate that. So d2a dr2, differentiating that, we get 2 pi plus 8000 over r to the power of 3. So let's see. This is negative, it goes there, it's positive. Okay, that's fine. Okay, and then we substitute the cube root. But here, even without substituting, I can see that my answer is going to be positive because all the terms are positive. I'm substituting a positive number over here. The cube of a positive number is also positive. So whenever I add positive numbers, my answer is always positive. So this, when r is equal to the cube root of 2000 over pi, this is 2 pi plus 8000 over the cube root 2000 over pi cubed, and then our answer should be 3 pi. We have 8000 divided by 2 is 4, oh no, it's 4 pi, so 4 pi plus 2 pi is 6 pi. So this is 2 pi plus 4 pi, which is 6 pi. And this is positive, and when our second derivative is positive, we know that we have a minimum. Okay, so now that we know that we do in fact have a minimum when the radius is the cube root of 2000 over pi, we can work out what the minimum area should actually be. So now the minimum area we use the formula for the area. The formula for the area is this one here. So we have pi times the radius squared, so it's the cube root of 2000 over pi squared plus 4000 over r, which is the cube root of 2000 over pi. So this, type in on your calculator, you get 697.468 centimeters squared. Okay, and what's interesting about some of these questions is if you were to actually take a 2-liter cylinder of different objects made by different companies, you would notice that most of them, the dimensions are the same. Now with like cans of cool drink, for example, most of them are the same size, whether it's Coke or Fanta or whatever it is, as long as it's 330 millimeters. And that should make you wonder, why are they all the same sizes? Because somebody has calculated what the minimum amount of area is to make that can, and then they all pretty much stick to that, because you obviously don't want to use more material than you need to make the can, otherwise it's more expensive. So the same thing is true over here. So tomorrow we'll look at some more examples and then do exercise 1.7.2. Not a lot of questions, but some interesting ones. So we'll stop here for today, and then tomorrow we finish off at 8:30.